We are choosing the clock of the atom over the clock of the Earth. This means that, over time, our official clock time, UTC, will slowly drift away from solar time, the time based on the Earth's spin. The sun might be at its highest point in the sky a few seconds, and eventually minutes, after our clocks strike noon. This decision marks a fundamental shift in how we define time. We are choosing the clock of the atom over the clock of the Earth. What if this trend of acceleration continues? What does a faster spinning Earth look like in the distant future? Scientists are exploring several fascinating, though highly speculative, possibilities. If the current acceleration is just a short-term blip, then we may soon see a return to the long-term trend of slowing down, dominated by the moon's gravitational pull. However, if the forces causing the acceleration, post-glacial rebound, potential changes in the core mantle dynamics, prove to be more dominant and persistent, we could be entering a new epoch of planetary motion. A consistently faster spin over geological timescales would have profound effects. The most fundamental change would be a shorter day. This wouldn't happen overnight, but over millions of years, the 24-hour cycle we take for granted could shrink. This would have massive implications for the evolution of life. Biological rhythms, or circadian clocks, are deeply tuned to the length of the day. A more dramatic and long-term consequence would be a change in the planet's very shape. The centrifugal force at the equator would increase, causing the Earth to bulge out more around its middle. This could alter sea levels, with water tending to pool more at the equator. It might also affect tectonic activity. It might also affect weather patterns. The Coriolis effect, which influences the direction of winds and ocean currents. A faster spin would mean more powerful and tightly coiled storms, changing the face of our global climate system. It's crucial to remember that these are extreme, long-term scenarios. The changes we're observing now are measured in milliseconds per century. We are not on the verge of a planetary catastrophe where we'll be flung off the surface. But studying these trends gives us an incredible insight into the powerful and subtle forces that govern our world. It reminds us that we live on a dynamic planet, not a static stage. The Earth has changed its speed before, and it will change it again. The scientific challenge, and the adventure, is to understand why. When we look up at the cosmos, we see a universe in constant motion. Galaxies collide, stars are born and die, planets spin on their axes. Our own planet is part of this grand, dynamic, celestial dance. The fact that its spin is changing is not a sign of malfunction. It is a sign of life. It's a message from the deep interior of our world, from the shifting continents, from melting ice caps, all communicating through the language of physics.